Okay, if we're talking about force in science, the name or the word Newton always comes up. And the reason why is because much of what we know about forces comes from knowledge that this guy gave us, Sir Isaac Newton. So, in addition to being a delightful breakfast cookie, actually it's delightful if you have it with milk, otherwise it's a little bit dry, but it's the unit that we use to measure force. So Newton is the unit of force. You're probably used to the pound as the unit of force that you'd use, but newtons is what we use in science because it fits in with all the other measurements that we use in the metric system. Okay, so the unit of force, how do we understand this unit of force? Well, I guess the first thing I want to do is I want to talk about a mass. So you've got a mass, let's say some block sitting on the ground, and it's not moving, its velocity is 0. If you want to move that mass, what do you need to do? Well, you need to apply a force. So when you apply that force, what you do is you change the velocity from 0. It's not going to be 0 anymore. So what you're doing when you apply that force and move that mass is you are accelerating it. The same thing goes if you have an object that's already moving. Let's say this box is sliding along and you want to stop it. So what would you do? You would apply a force to stop it. So basically, what forces do, and they don't have to do this, but they can change the motion of objects. And if force is balanced, then you might not have any motion at all. So that's why I say forces can change the motion of objects. They don't have to, but they can. So anyway, getting back to this notion right here, we've got a force acting on a mass to cause an acceleration. And remember, an acceleration is just a change in velocity. And so that can be a change of speed and or direction. So it doesn't have to make it go faster or slower. It could just turn it. So a force can cause an acceleration just by turning an object. So what are these measured in? Mass, we measure in kilograms. Acceleration, we measure in meters per second squared, or meters per second per second. So when you multiply those two together, you get the Newton. Okay, so if you have 1 kilogram and you want to accelerate it at 1 meter per second, by Newton's second law, which is F equals m times a, you multiply this by this and you get 1 Newton. So actually the Newton is an abbreviation for the kilogram meter per second. Okay? So let's get a grasp of what a Newton actually can be, like what can represent a Newton. So something that has a force of about a Newton, like a small apple. If you have a small apple, that is about 1 Newton. So a small apple is about 1 Newton. So someone like me, who's a whole bunch of small apples, it would take about 800 of those to make me up. So I'm something like 800 newtons. Some other objects, how about this? A paperclip. A paperclip can be, I mean, there's different sizes of paperclips, but a paperclip can be about 0.01 newtons, about 100th of a newton. Or how about something like this? Look at that. I mean, the space shuttle, I don't know if you guys remember this going off. Maybe you're just too young, but this thing has these rockets that apply this giant force downward that moves the space shuttle upward. How strong do you suppose those rocket engines are? Those rocket engines have a force, or if you're a space geek, you'd call it thrust. They have a force of 3.15, about 3.15 times 10 to the 7th newtons. So what is that? 10 to the 7th is, you know, tens of millions. So the space shuttle had a force of tens of millions of newtons. So just a quick recap here. If you have a mass, oops, that's a bad color. If you have a mass and you want to accelerate it, that could mean an object sitting still and you want to make it move, or it could be an object that's moving and you want to make it move less or in some different direction, then you need to apply a force. And that force is measured in newtons. And the newton is an abbreviation for kilograms times meters per second per second. Okay?